Hello, today we're going to look at section 7.3, the slope of a line. Now by definition, the slope of a line is the ratio, now notice this is a word we have talked about before, the ratio of the vertical change to the horizontal change between any two selected points on the line. Another way to think about the slope of a line is to think about it as being the steepness of the line. Now let's start by looking at a couple of points, and we will take this definition and rewrite it in a couple of ways. So let's say that I plot the point 1, 2, and I also plot the point 3, 5. And I want to take a look at the definition of the slope in relation to those two particular points. Now notice it says it's a ratio. So that tells me then that slope is equal to a fraction of some sort. And on top of that fraction is the vertical change. And on the bottom of that fraction is the horizontal change. So let's take a look at that with these 2 points. So if I look at the vertical change, that is my up and down change. So if I look at where my 2 is here, I would need to go up 3 units to get straight across from the second point there. So my vertical change here is in fact 3 units. My horizontal change, on the other hand, is going to be 2 units, because to get to this second point, I would need to move 2 units. So the slope for this particular line, we could say, is a slope of 3/2. Now this will work for any 2 points on the line. So if I were to sketch in my line here, and I'll try to draw it as straightly as possible, I could pick any other point. So notice if I were to also pick this point, which appears to be on the line, notice that the change there also is 3 units in the vertical and 2 units in the horizontal. So with this kind of a situation, we actually have a little formula. And the formula basically tells us that given any 2 points, and we'll call those points x sub 1, y sub 1, and x sub 2, y sub 2, and the sub 1s and sub 2s simply mean that these ordered pairs are actually on the same line that we're looking at. When we look at it in this particular way, we can say that the slope is in fact equal to the change in the y, because remember our y coordinates are the ones that are always vertical, over the change in x, which is our horizontal change. So our vertical change and horizontal change we can also think of as a change in y and a change in x. And when we do that, that change is really a difference in those coordinates. So we can write it as y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So when we take all of this information and write it in terms of symbols, this will actually become m. That's what the letter we typically use to refer to slope. M is equal to, and in symbols, change in y, we use a little triangle to represent change in y, divided by the change in x, is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And this is the little formula that we will use to be able to find the slope if we know any 2 points on a line. So let's take a look at an example here. Let's say, for example, I want to find the slope of the line through the points 5, 1 and 3, 8. Okay, those are the 2 points that are on this particular line. So what I'm going to use is my slope formula that says m is equal to y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Now, before I start plugging in information into this particular formula, I want to make sure that I am plugging in the right coordinates in the right spots. It's very easy to mix these up. So what I'm going to do is I'm going to put above this first point x sub 1, y sub 1. I'm going to call that my point 1. And this is going to be x sub 2, y sub 2 to represent my point 2. So now when I go to plug in my values into the formula, I can just look at where I've labeled those. So y sub 2 is 8 minus my y sub 1, which is 1, and that's divided by my x sub 2, which is 3, minus my x sub 1, which is 5. So 8 minus 1 gives me 7, 3 minus 5 gives me negative 2, and so therefore I can say my slope here is negative 7/2. Again, the negative can be on the bottom, on top, or out to the side. Now some of you might be wondering, well, how did you know to make this your x sub 1, y sub 1, and this your x sub 2, y sub 2? Well, the beauty of the slope formula is that you can look at these points in any order. So let's say that instead of viewing it as I did before, I took these 2 points and I said, no, I would like this one to be my x sub 1, y sub 1, and this one to be my x sub 2, y sub 2. Well, what would happen now if I use the formula for this particular case? Well, again, remember, m is still going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But now I'm going to have 1 minus 8 over my x sub 2, which is 5, minus my x sub 1, which is 3, and I end up with negative 7 over 2. Notice I'm still getting the same fraction as I did up above, because whether the negative is on the bottom or on the top, it's still going to give me a slope of negative 7/2. So it doesn't matter which way you view the 2 points. You can view them in either order and you will still be able to find the slope. Now, one thing to think about with your slopes and to be aware of is that a line with a positive slope always rises from the left to the right. In the same way, a line with a negative slope always falls from left to right. And so that's a couple of things to keep in mind. So if I were going to look back at the line we drew at the very beginning of this lecture, you'll notice that this line is actually rising from the left to the right. So this line does have a positive slope of 3/2. Again, left to right, the line is going up. So remember, positive slope will rise left to right. A line with a negative slope will fall left to right. So if I look at an example of what would happen with this particular line that we have right here, now let's suppose I start with the point 5,1. There is that particular point, and I could say I need to be able to go down 7 units. So that would be 1, 2, 3, 4, 5, 6, 7. I'd go down 7 units and over 2 to get another point on this line. And if I sketch this line in, there would be the line that contains the point 5,1 and also the point 3,8. But notice if I go left to right, it actually falls left to right. Okay, so now let's take a look at our two special cases. I'll start out with a fresh sheet here and let it get focused. Hopefully it will focus here. And I'm still waiting for it to focus. And we'll stop, and I'll try another lecture with that.